In my previous video, I showed you guys how you could turn your Pluto SDR into a Spektrum analyzer on Windows using the SAT-SGen software. I've been listening, and it's very obvious that a lot of you are looking to do something very similar with the basic RTL-SDR. Well, today we'll be taking a look at an application called Spektrum that works on both Windows and Linux that will allow you, with a few extra components and a noise source, do the same thing, such as measure filters using your RTL-SDR. My name is Sarah, and you're watching Signals Everywhere. Today's video is brought to you by Audible, the best way to listen to books on the go. Sign up at audibletrial.com/Signals Everywhere and get 30 days free trial and a credit for a free audiobook. Cancel anytime at audibletrial.com/Signals Everywhere. Let's go ahead and fire up our RTL-SDR, get that plugged into your computer. Once it is ready to go, fire up the application, and you'll see that we automatically get a select device dropdown. This should be already populated with your RTL-2832U, or otherwise known as your RTL-SDR. Go ahead and click on that option here. As the program starts up, you'll see it will begin to do an initial sweep of the frequency range for the RTL-SDR. The default range here, it is scanning from 24 megahertz to 1.8 gigahertz. Let me give you a quick rundown of what we have available in the software, and then we'll jump into measuring a filter, and then I'll show you how we can take a look at very wide swaths of bandwidth using only the RTL-SDR. Our first option here is going to be our receiver range. This will allow you to select a start and end frequency. These are set up in hertz, not megahertz, so make sure that you are calculating these correctly as you enter them into the software. You also get a option to adjust your bin size. I tend to leave this alone. And then from here we have our set range button that will allow us to set whatever our chosen range is. Our RST buttons here are used to simply reset these frequencies to their initial values. So if I backspace all of this and then press the RST button, this will reset to that 24 megahertz default, and you will see another initial sweep begin to take place. One thing to note here is that you want to make sure that you are always using a backspace to remove numbers and that you do not press the delete button. It seems that the software is a bit picky when we enter numbers here, and if you're not careful, occasionally the application does freeze and crash. If you have this problem, I recommend simply closing the program and reopening it. Next here we have an up and down converter option. This will allow you to enter the IF frequency of an up converter or a down converter. This would be an example of, say, the HF up converter by Ham It Up, or, for example, an LNB, which could be used as a down converter for satellite frequencies. We also have various options, quite literally and figuratively here. We can show and hide our cursor information. So these little guys here, if I right-click on the screen, we can move all of this stuff around. And we can also actually drag to create lines here and help us do various measurements. If we click the cursors button, that'll just hide all of that for us. Let's go ahead and press the sweep button so that we have a new sweep showing up here. As this begins to do its sweep, you can see we have a line dot option, which just changes the representation on your screen. We also have the filled graph, which will fill in everything below the specific noise level here, so that way you can get a different perspective on the signals coming into your RTL-SDR. You can enable and disable offsets tuning, which would be helpful for essentially turning on and off the up and down converter details in software. And you can also show and hide the minimum and maximum signal levels of the various previous sweeps that you've done since starting the application. And then we also have our configuration presets. This will allow you to save a copy of your settings and then load them up later. So if you have things that you're doing often, like measuring certain filters for specific bands, you can just automatically load up the configuration with the settings that you need for that job. Next, we'll move over to the Measure tab. We have our vertical scale and RF gain. So this is going to let us change the amount of gain that's coming in with our RTL-SDR. We can change this by just clicking on these little bars here. We can change it by moving this back and forth or up and down, and we can also scroll to change this. You can automatically use the auto scale to actually scale your range here. You can also reset that scale, and then you have the option to set a lower and upper scale limit, and then set that scale manually. We have the option for video averaging, as well as the ability to take a capture of what's currently on our screen to use as a reference. You'll see that when we press the save reference, this will change another color, and then we can show and hide this. This comes in really handy, so say that you have a pass that is different from a previous pass. Now you can show and hide that reference to get an idea of how much that signal has changed over time or over various changes, such as tuning a filter, for example. And we can also show the maximum, medium, and minimums for any various signal sweep that we do. And then finally, there is relative mode, which we will get to in just a moment, because right now I'd like to go ahead and begin measuring our filter. So to do that, the very first thing I'd like you to do is come over here and set your gain to 0. And you can do that real quick by just tapping this first little box here. We need to have the gain at 0 because we are going to be using a noise source on our input. And if we don't have our gain turned down, our results will be drastically washed out. And in my case, I wasn't even able to measure a filter when I had gain turned on. So turn this off first, then we're going to move over to our setup tab. Now the RTL-SDR FM filter is advertised from 88 to 108 megahertz. I like to bring a range into the Spektrum Analyzer software that's a bit wider than that, so I can see how the signal is tapering off as it passes through that filter. So let's go ahead and we're going to change our start frequency to 50 megahertz. And then I'd like to set our end frequency to about 150 megahertz. Now that we have our frequency range set from 50 to 150 megahertz, you can see that reflected on the bottom here. Keep in mind that this frequency is entered in hertz, not megahertz, so make sure you're calculating accordingly for this. Back over to the Measure tab, and let's go ahead and press the Relative Mode button. Now, once we have relative mode set up, we are ready to go ahead and connect our noise source. Go ahead and connect that noise source and power it on. Now, if you purchase the noise source that's in the link in the description below, keep in mind that mine came without a case, and it does get very hot. So be careful when it comes to touching and handling the device, and make sure that you're not shorting it out on anything else on your bench. Now you can see that once this is connected, the signal is slowly rising. As it does each pass, it is taking a relative measurement. Once each pass seems like it is moving relatively not at all, we can press the Set Relative button, and you'll see that it shifts everything to 0 dB to give us a nice average starting point of what our signal source should be. Since we're here, I'm going to go ahead and press the Save Reference button as well, just so we have a copy of that if we want it later. And I'm going to hit the Show button to temporarily hide that for us. Now that we have our relative, let's disconnect the noise source, and we'll be connecting the RTL-FM broadcast band filter in between the noise source and your RTL-SDR. I'll put a picture on the screen just so you can see exactly how that should be connected. From here you can see that there's already been quite a drastic change to the signal that we see here. If I press that Show button next to our reference, you can see where that baseline has moved quite dramatically. And so essentially what we are doing here is we're passing a constant RF signal across the band that we are sweeping back and forth to view. And as we put our filter in between it, we are seeing the signal loss and the dips where that filter is actually tuned for. Now, from this angle, everything is pretty well zoomed out. What I tend to do, especially with filters, is just hit the auto scale button here, and you'll see that brings everything forward for us. So you'll see we have our 0 dB base point here, and then because this is an FM blocking filter, we actually have a signal dipping down negative dB. So if we click down here, right click on this point, you can see that it looks like it's showing about negative 21 dB of signal loss at 113 megahertz. So now, unfortunately, what I have noticed with this software, when you compare it to Satsigen and the Pluto SDR, your signal level and the signal loss that you are reading is going to be vastly inaccurate. The particular filter we're looking at here, I believe, was advertised at its peak, should be about negative 50 dB. And unfortunately, we're just not seeing solid results here. I've also frequently seen 15 dB show up when measuring this filter using the Spektrum software. That being said, Satsigen was able to read a much more accurate measurement, coming a whole lot closer to the advertised level that we came to expect. Now, that being said, just because the power measurement may not be super accurate doesn't mean that this isn't useful. We can obviously see where our filter is working along the band. So you can see how this is tapering the signal strength as soon as we get to roughly, I'm going to say about here, 77 megahertz. And at 88 megahertz is where the filter is actually supposed to start. So if we look at this first nice big drop here, you can see that's at 88 megahertz, roughly, give or take. So from 88 megahertz to about 114, you have a really nice amount of immediate signal loss here. And you can see how that's going to help you reject those FM broadcast band signals. While we're in here, I did want to go ahead and turn this video averaging on as well. You can see this works out a little bit differently when you're currently measuring a signal. It kind of makes the previous scan or previous trace sit there just a moment longer, and it gives you a nice idea of the change between each sweep. Now, we're not seeing huge changes here because this is obviously a passive filter, but this is a useful option nonetheless. We also have, again, that minimum, medium, maximum options as well. So with that said, measuring the filter is pretty easy to do with the noise source. From here, I wanted to show you just how simply we're able to go and do a scan of a very wide swath of bandwidth, something that typically you're not going to be doing with an RTL-SDR. So let's go ahead and hit cancel relative now that we have disconnected everything and connected a proper antenna to the SDR. I'm also going to increase our gain because now we want to actually look at the spectrum that's out there rather than what's coming in from our noise source. I'm also going to go ahead and tap the auto scale button again just because we've made some changes here. So this is actually looking at 50 megahertz to 150 megahertz right along that FM broadcast band. And you can see some obvious radio stations here at 90 megahertz, another one at 97, one at 102. This is actually 102.5. And you have just various radio stations that you can see popping up here. If we go back over to setup, generally you want to have the sweep option on. I think because we were in relative mode, it decided to continue sweeping. The software is a little odd with some bugs like this, but typically you're only going to get one sweep unless you have the sweep mode turned on. So I would recommend that we go ahead and hit sweep just because we're measuring something passively, and we're also going to go ahead and turn off the cursors. So let's go ahead and measure a really big swath of RF signal, something that you typically would not be able to measure with an RTL-SDR. Keeping in mind, your maximum theoretical bandwidth here is about 3.2 megahertz, but with this, we're able to measure full-blown swaths of spectrum all at once. So for example, let's go ahead and start at 800, and we're going to sweep between, let's do 800 to 900 megahertz. So now we're seeing the swath of spectrum from 800 to 900 megahertz, and this actually looks like our GSM band right here. Let's go ahead and turn that gain up though, so we should be able to see things a little bit better here. So this is a lot of GSM stuff. Let's look for 855. Might not be able to see it in all the noise, but we're definitely seeing some GSM. So I thought what would be interesting here, because I haven't done this in a while, let's see if we can find the signal coming from my cell phone when I make a phone call. I haven't done this since I tried this with the original Spektrum Analyzer software that came out for the HackRF, which I believe is called the HackRF Analyzer. So as per usual, I'm going to call the 800 number from my childhood, which would be Nintendo, 800-255-3700. Let's make a call here. So I've actually sat here a while, and it looks like I'm not going to be able to find my phone. I believe the reason for this is I was actually forced to switch phone providers, and I used to know exactly where this signal was showing up, and it's possible that the new phone is actually completely outside of the frequency range of the RTL-SDR. That being said, it's obvious that you are able to look at a very wide swath of spectrum by doing these very large sweeps and then comparing to that historical and analytical data that it's pulling up on your display. With all that being said, I do believe this still shows us that we're able to see a very wide swath of RF spectrum, which is something that you just typically cannot do with an RTL-SDR on its own. Using a typical waterfall display that you would do through an application like SDR++, SDR Sharp, SDR Console, or any of the other various applications that we've worked with on the show in the past. Hopefully this video is able to help out somebody there. Hopefully this video was able to help somebody out there who has an RTL-SDR and really wanted to be able to take some measurements. Despite them not being super accurate, at the very least, you can see the characteristics of your filter, and it does give you different options for measuring filters and looking at wide swaths of RF spectrum, which is really just something that you typically can't do. And I've only said that 50 million times. So with that being said, I'll stop being the broken record. Thank each and every one of you, especially all of my loving patrons who have been keeping me up and at it through these hard times. It's very much appreciated. And I hope to see each and every one of you in the next one. Bye.